Let us start relation and function. Today's target is reflexive relation. We have already learned about relation in class 11th. Let us take a look what we have read earlier. In class 12th, relation and function is of 8 marks and it consists types of relation: reflexive, symmetric, transitive and equivalence relation, one-to-one and on-to function, composite function, inverse of function and also inverse trigonometric functions. Firstly, we recall relation what we have learned in class 11th. We have learned what is a relation, its domain and range, meaning of a relation on a set, number of relations from A to B, number of relations on A. First, we recall what is a relation. We know every subset of A cross B is called a relation from A to B, and symbolically it is denoted by R is a relation from A to B by this symbol. The relation R symbolically expressed as set of ordered pairs. Here, if ordered pair AB is in R, it means element A of set A is related with element B of set B. Observe this figure. In this figure, A and B are sets and a relation is defined from set A to B under which 1 is related with 8, 2 is related with 5, 4 is related with 5, 4 is also related with 6. So R is a relation from A to B. In this relation, 1 is related with 8, denoted by this. Similarly, 2 is related with 5, 4 is related with 5 and 4 is related with 6. This fact can also be written as R is a relation consisting following 4 elements. Each element of R is an ordered pair. Take the first ordered pair 1, 8. If ordered pair 1, 8 is in R, it means element 1 of the first set, that is set A, is related with element B of second set, as we are seeing in the figure. 1 is related with 8. Ordered pair 2, 5 means element 2 of set A is related with element 5 of set B, and same meaning for ordered pair 4, 5 and 4, 6. Take another example. Here, relation R is defined from A to A. It is called a relation on A. In the figure, 1 is related with 1, 2 is related with 1, 4 is related with 4 and 5. This is also a relation from A to A, or simply it is a relation on A. In this relation, 1 is related with 1, 2 is related with 1, 4 is related with 4, and 4 is related with 5. One element can be related with more than one element. If we write R in tabular form, then R is ordered pair containing 1, 1, 2, 1, 4, 4, 4, 5. From this ordered pair, we mean that first element 1 is related with second element 1. The first element is from first set, second element is from second set. In this case, when we define a relation on A, first set, second set both are equal. Now observe or recall following two points. Set of first entries of elements of R is called domain of R. In the figure, set A, elements of 1 to 4 of set A are first entries. So what is domain? Set of first entries of elements of R, 1, 2, 4. Similarly, set of second entries of elements of R is called range of R. So what will be range in this case? See, 8, 5 and 6. Also, we recall if number of elements in A is P and number of elements in B is Q, then number of elements in A cross B is necessarily P into Q. Therefore, number of subsets of A cross B will be 2 to the power P into Q. As we know, if a set has n elements, then it has 2 to the power n subsets. Here, A cross B has P into Q elements. So, number of subsets of A cross B will be 2 to the power P into Q. Therefore, number of relations from A to B, since every subset of A cross B is a relation from A to B, so number of relations from A to B is 2 to the power P into Q. Clearly, number of relations on set A, that is, it is a relation from A to A. If A has P element, then A cross A has P into P, P square elements. So number of subsets 2 to the power P square. So number of relations on set A, that is from set A to set A, 2 to the power P square. These all things we have already learned in class 11. We have taken just a look and just we recall our previous knowledge. Now we will come to the syllabus of class 12. In class 12, we have to learn types of relations. There are mainly three types: reflexive relation, symmetric relation, transitive relations. Their combinations involve equivalence relation. Let R is relation on A. We know a relation from A to A is called a relation on A. Means reflexive relation is defined only when relation is from same set to same set. If for each A belonging to A, ordered pair AA belongs to R, then R is called a reflexive relation on A. But definition says if A, small a, is any element of the given set, then ordered pair AA should belong to R, should be in the relation. What we mean by ordered pair A belongs to R? It means element A should be related with itself. That is, if each element of set A is related with itself, if A is in set A, then A should be related with A, and this should be for each element of set A, not for few elements, for each element. Then R is called reflexive on set A. We will clear this definition by few examples. Consider this example. First see, it is relation or not. Necessarily it is a relation on A. A has 4 elements. 1, 2, 3, 4. Now observe this relation from A to A is reflexive or not. As per definition, a relation on A will be called reflexive relation if each element of A, each element of this set, is related with itself. Observe, 1 is related with 1, 2 is related with 2, 4 is related with 4, but this element 3 is not related with itself. So, though it is a relation, but it is not a reflexive relation. Why? Because definition is not satisfied. As per definition, each element of set A should be related with itself, and here there is an element 3 which is not related with itself. So, the relation is not a reflexive relation. Take another example. Here we observe that each element of set A has 4 elements, 1, 2, 3, 4. 1 is related with 1, 2 is related with 2, 3 is related with 3, 4 is related with 4. So we observe that each element of this set is related with itself. So the relation is reflexive on A. R is a reflexive relation on A. Take another example. Here R is a relation from A to A. R is a relation on A. A has 4 elements, and observe 1 is connected with 1, 2 is connected with 2, 3 is connected with 3 as well as with 2, and 4 is connected with 4. Now question arises, this relation is reflexive or not? Our definition says, definition of reflexivity says, if, see the word, if, for each A belonging to A is related with A. You observe 1 is related with 1, 2 is related with 2, 3 is related with 3, 4 is related with 4. The definition does not say that any element may not be connected with some other element. It may be possible that elements of set A may be connected with some other elements of the set A. It does not affect our definition. As per definition, we have to see only one thing, whether each element of the set is related with itself or not. And here we observe that each element of set A is connected with set A. So necessarily this is a reflexive relation. Is it clear? When A relation will be called a reflexive relation. The first condition, the relation should be on a set, means from same set to same set. Then question of reflexivity arises. Now, if each element of this set is connected with itself, then the relation is reflexive on A. Doesn't matter if some element of A is connected with some other elements also. It may be possible. They may connect it. We have to see only one thing as per definition, that whether each element of the set is related with itself or not. If yes, it is reflexive. If there exists only one element which is not connected with itself, then only we say that it is not reflexive. Take one more example. In this example, we have to state whether R1, R2, R3, R4 are reflexive on A or not. Set A is triplet. It has three elements, 1, 2, 3, and following relations are given. Consider first relation R1. State whether R1 is reflexive on A or not. We observe A has three elements. 1 is related with 1, 2 is related with 2, but 3 is not related with 3. So R1 is not reflexive. See R2. In R2, we observe element 1 of A is connected with itself. Element 2 of A is connected with itself. 2 is present in R2. 3 is connected with itself. So R2 is reflexive on A. R3, 1 is present, 2 is present, 3 is present. Whether some other elements are present or not doesn't matter. We have to see only one thing, that each element of A is connected with itself, so it is reflexive. R4, A cross A. State whether R4 is reflexive or not. Clearly, A cross A consists now observe 1 is present in R4, 2 is present in R4, 3 is present in R4. So each element of A is connected with itself. Therefore, R4 is reflexive on A. We observe here there are so many other elements. They may occur or may not. It does not affect our definition. The definition simply says if each element of A is related with itself, then it is reflexive. See another example. B has 4 elements A, B, C, D. State R1 is reflexive or not. Then we have observed only one thing, that whether each element of B is connected with itself or not. That is, we will observe whether R1 consists of the pair A, B, B, C, C, and D, D. If each of these are present in R1, it is reflexive. If any one is missing, it is not reflexive. Ordered pair AB is present, doesn't matter. A is present, so A is related with A. B is related with B, as ordered pair BB is present. C is also related with C. But ordered pair DD, D is present in B, and ordered pair BB is not in R1, so R1 is not reflexive. What about R2? Ordered pair A, B, B, C, C, D, D. So necessarily R2 is reflexive on B. What about R3? B cross B. Necessarily B cross B will contain. So necessarily A is present in B cross B. BB is also present, CC will be present, BD will be present, so R3 is also reflexive. See, this is last example. Let L is the set of all lines in a given plane, and R is a relation defined on L, given by R will consist those ordered pairs AB if A is parallel to B. What are A and B? A and B are elements of L. What are elements of L? Elements of L are all lines in a plane. Suppose this is the plane, necessarily this plane will contain infinite lines. There will be infinite lines in this plane. All these lines are in the set L. Suppose this line is A, this line is B, this line is C, and similarly there are infinite lines in this plane. All are in this set. And when any element X of this set will be related with some element Y of this set, when line X is parallel to Y. So we have to observe whether this relation on L is reflexive on L or not. Observe. Let X belongs to L. But we say X is any element of L. That is, this X represents each element of the set L. And we know L has infinite elements, all are lines of a given plane. So, since X is a line, therefore X will be parallel to X. Is it clear? Why? Why X will be parallel to X? So simple. Since every line is parallel to itself, so X is parallel to X. This implies X is related with X because this is definition. When A will be related with B, ordered pair AB belongs to R means A is related with B. When A will be related with B, when A is parallel to B. And we are observing X is parallel to X, so X is related with X. So ordered pair XX belongs to R. And this will be true for each element of L, for all X belonging to L. So whenever X is any element in L, ordered pair XX will belong to R. Therefore, R is reflexive on L. This is all about reflexive relation. We will see more example in combined form in the unit of problems, and our next lecture will be symmetric relation. We will see on next lecture. Thank you.